Cities with more police officers often have more crime, people who play golf often live longer, and successful people often wake up early. So do police officers cause crime? Does golf extend your life? Will setting an alarm for 5 in the morning make you successful? Maybe. But none of those statistics proves it. And if you do not understand why, you can be manipulated by almost any headline, health scare, or self-improvement guru. There is one sentence that can change the way you see the world. Correlation does not imply causation. Years ago, during the final session of a master's-level statistics class at Duke, the professor told the class, "You may forget everything else from this course, but I hope you remember this sentence for the rest of your life." Then he spent 2 hours giving example after example. At first, the idea sounded almost too obvious, but over those 2 hours, its importance became clear. People confuse these two things constantly, and that confusion can be used to sell fear, certainty, and solutions. Imagine collecting data from cities around the world. You might discover that cities with more police officers also tend to have more crime. Does that mean hiring police officers causes crime? Probably not. Larger cities may have both more police officers and more reported crime. High crime may also cause cities to hire more officers. The same two numbers can move together for several completely different reasons. That is correlation. Two things appear together. Causation is a much stronger claim. One thing actually produces a change in the other. The difference is easy to notice when the conclusion sounds ridiculous, but most misleading claims are designed to sound reasonable. Suppose a study finds that people who play golf live longer. A headline might say, "Golf adds years to your life." That sounds plausible. Golf involves walking, sunlight, social contact, and time outdoors. But golfers may also be wealthier on average. Wealth can be connected with safer neighborhoods, better food, more leisure time, and better access to health care. People healthy enough to play golf may also be more likely to keep playing it, so perhaps golf helps, perhaps it does not. The correlation alone cannot tell us how much of the difference golf actually caused. This is where the sentence becomes useful in everyday life. Whenever someone hands you a confident cause and effect story, pause before accepting it. Ask, what else could explain this pattern? Maybe a third factor causes both things. Maybe the direction runs backward. Maybe people selected themselves into different groups. Maybe the measurement is biased. Or maybe the relationship is real but much smaller and more conditional than the headline suggests. Consider online claims about mouth breathing and a recessed jaw. You may see a collection of people with enlarged adenoids, long-term airway obstruction, characteristic facial development, and a tendency to breathe through the mouth. Then someone points to the pattern and concludes, mouth breathing caused this face. But that observation alone cannot separate the possibilities. An underlying airway problem may contribute to both the breathing pattern and facial development. The relationship may be bidirectional. Duration, age, sleep, genetics, and severity may all matter. There may be a causal effect in some conditions, but a photo collection cannot establish it. The point is not that mouth breathing definitely has no effect. The point is that the evidence being shown may not justify the certainty being sold. This mistake appears everywhere. Successful people wake up early, so waking up at 5 must make you successful. People who use a certain supplement report more energy, so the supplement must be responsible. Teenagers who spend more time online report worse mental health, so one platform must be the single cause. Couples who communicate more are happier, so forcing more conversations must always improve a relationship. Each claim might contain part of the truth, but correlation cannot tell you the full causal story by itself. And our brains love causal stories. A causal story feels complete. It gives us a villain, a lever, and a solution. This one habit created your problem. Buy this one method and reverse it. Uncertainty is harder to sell. That is why a simple statistical warning can become a form of psychological self-defense. The next time you hear X causes Y, ask 4 questions. First, could something else cause both X and Y? Second, could Y actually cause X? Third, were the groups different before the measurement began? And fourth, what kind of evidence would genuinely test the claim? Sometimes the answer requires a randomized experiment. Sometimes that would be unethical or impossible, so researchers use longitudinal data, natural experiments, careful controls, or multiple studies that point in the same direction. No single method is perfect, but stronger causal claims require stronger evidence. Correlation does not imply causation does not mean that correlations are useless. Correlation is often the first clue. It tells us where to look. It simply means a clue is not a verdict. You do not need to become cynical about every study. You only need to create a small gap between seeing a pattern and believing a story. Inside that gap is a better question: what else could be going on? That one question can protect you from bad headlines, bad marketing, and many beautifully packaged explanations. You can forget the formulas, but remember the sentence: correlation does not imply causation.